Okay, now getting back to the trueness, of course our machine's going to have to be square with the horizontal and vertical shaft also to actually replicate our hub that we have going around in circles. First, I got a dial indicator set up on this. You're not going to have to do this every time, but if it's in your shop, you might want to maintain it. I just want to show you how this sets up. Of course, I have this flat surface on this back side that everything's going to slide back against. That's going to be the flange. Then, of course, the armature itself, the arbor itself, then the whole way out needs to be true on its axis. If it has any up or down, your rotor is going to go up and down and not work right against the cutter, giving us a uneven path that could cause more brake wobble. In fact, I've taken rotors and had them turned and got back and had twice as much wobble as I had before by the people not chucking them up properly on these. So this gets your machinist now. This gets into lathe work and an understanding of a lathe on how to be proper on this to have a machine that works very good and so on there. Of course, my dial indicator is set up. I'm going to turn the lathe on and let the ball bearing on the end of the dial spin on it. And out of that, you can see about a half a thousandths waver on that. Well, of course, half a thousandths here, whenever I could come out, could end up being 3 thousandths of an inch the further or the further in I go on this. So this is important. I'm going to have to clean that up. I'm going to take a whetstone, lightly hit this just to see if there's any dirt or debris from over the years, crud, grease alone, oils off of our hands alone building up on that could have produced that waver there then. Next, I'm going to take the dial indicator and let's get him moved around here a little bit. And we're going to put it on the armature itself then, on the arbor. And with that, I preload him. Haven't checked it yet. But we're going to see how much run out we get on this. Now, hopefully my dial indicator don't float around too much and fall. And then if I turn my arbor or my electric on, allowing the arbor to rotate, and note I'm clear out on the end of this guy or close to it, which is going to give me an exaggeration of everything that's up close there. Seeing about a half a thousandths on that too. That's really good for a machine around here that's been abused and so on like that. When I say abused, everybody takes a rotor, drops it on this guy, let it clang and so on, so you're bending that shaft every time someone drops that on that. I'm amazed that it is that close on this one. Okay, so that gives us our centering devices there. Next, let's do a build up or a stack up of the devices that would then allow our rotor to be mounted. We said before that we're going to have a hubless adapter. And on this hubless adapter, again, I went through the other day and I machined all the surfaces on this. So off of squareness off the back. So this surface and this surface, as of right now, square until someone drops this on the floor. Of course, we're going to slide him back the whole way. And he's found his centering ability by being pushed back. And when I say pushed back, watch the amount of wobble that actually happens in this because it is loose on the hub. And you can see that going on. So again, it's going to be pressure pushing back on this that literally is going to flatten this unit out on there. So we've got that adapter. Now we're going to go with a conventional setup on putting our centering device in. It's going to be done a couple of ways and I'll show them to you. First off, we're going to put a spring, and the purpose of that spring is to drive this centering device into the center of the rotor so that it finds the circumference that the rotor actually exists in it. And it gives us the ability to do back spacing as we get a different hole versus where the back of this unit is. One thing we do have to watch on assembly, there is a such thing as running this in too far or using too big a one that it bottoms out. And then your rotor sits only on this circle, not on these fingers on the hub above. So let's see how we're doing here. I then take my rotor, and we're going to check and see if it can go back and clear those. And I got back my cutters out a little bit. And if I shove that in, we're very good. I've got a good bit of this taper sticking out, so that's telling me I'm not at the closeness that could have shoved that back into the actual hub and bottomed it out. So right there is where I'm going to find squareness based on the back of that. Next, I'm going to take my other hub adapter and put it right there. Now we can see on this one, those fingers are right on the inside. So I'm going to grab a different one. I don't like the height of that. This one's closer to the diameter of the other. I like pushing on the bolt holes, not on the center of it. And there we go. I like pushing there better than in the center so that I don't distort my plate. Now all I gotta do is find a spacer, a clutch, and the nut then, along with this. The clutch and the nut might be enough, but I might also need a spacer. And again, we could have used the ball bearing units, or we could use a regular spacer. And in this case, all I need is the clutch assembly, the self-aligning unit. It does leave this much shoulder. We say, well, wait a minute, the nut won't go down past those, but what if I use the part that's counterbored out? And that can make up that space on there. So with that, it's simply taking him in, making sure that I like bumping around so that everything settles a little bit. It helps a tremendous amount. You'll see a dial indicator. If you had a dial indicator on it, you'd see it jump all over right there. And then of course I just need to take a wrench and snug this guy down. Of course it is left-handed threads. That's usually tight enough right there, which at this point, all trued up and squared up on everything, should allow this unit to oscillate. I'm clear of everything, my shirt's not in the way. And what we're going to be seeing is something of this nature right there. Now, if I took a screwdriver or anything and I went this direction and held it still, you can physically see at this point how much run out there is. We could put a dial indicator on it, but it's very easy for you to do something or even look across and find a mark back here and see how much run out's gone on, to see if it's excessive, to see if maybe I'm not even close, and I'm not going to try that at all. Okay, next for cutting this unit, it's very simple then. I'm going to go to the very left handle and I'm going to move this guy out to where I'm centered in the cutters. I've already backed off the cutters, pulled them back in. I'm going to center it up. And you can see the two cutters down here, little triangular cutter pad on them that is replaceable and reversible. We can actually reverse this guy, turn him upside down. There's one new cutter that has the carbide, and it's only that little skinny line on that little point that's making the cut. So it takes a while to get all that out there. We're not taking large materials out at a time. All right, now the left to right attachment, I'm going to snug it down. There's a lock mechanism just like east tabs on the left or right. I'm going to lock it down. I'm then going to come in and I'm going to go right to about the middle with my cutters on there. And then we're going to turn it on. We're going to go in. We're going to then run our cutter in and see how far we are off. Again, looking to see if did I mismount this thing or so on there. So let's try this once. Bringing it out. And you could hear where I was off on that one. I'm going to go to the other side. And you can hear how it's hitting a small amount. It's out of squareness there. Here's a great way on any lathe device to see if maybe is us that mounted it wrong, or to see if maybe it just actually is warped. I'm going to loosen the nut. Then I'm going to take and I'm going to rotate the rotor 180 degrees on my inner hub right there. So remember, that's the flange that brings him back in. I'm going to relock it down. I'm going to bring you over on the side here because we put a scratch on the rotor when we put that cutter in there. I'm going to spin it around and see if we can actually find a spot that I put a scratch on it. And it's not showing up real good on the camera. I'm looking through the camera trying to find it. Let's go to the inside. Maybe that one I got a little more light, and it'll show up for you in there. And that's literally on this rust line, right? Get a line on it right there. Okay, so that actually indicated where we was. Now, I'm going to bring my cutters out a little bit. I'm going to bring it out, and I'm going to make another path and see if it is opposite of where it touched here. Let's find out. Now, we squared it up a tremendous amount. If I go to this side on the cutter and do the same thing, you can hear how much squarer it is, so that's saying that we even settled it down a little bit. And that's going to be a judgment call on your part on getting that set up like that. Now, let's go ahead and take a big overview of this and see what we do next. Finish this out. All right, I'm going to take this guy in. I'm going to go till it touches. Then I'm going to zero my micrometer on top. And there is metric and there is micrometers on top of this guy, in thousandths of